So in this case, all you have to do is to identify the independent variable, the dependent variable, and explain how would you obtain the antiderivative of that function. Okay?
Okay. Okay, yeah. So first, we can write this. Can I get some like a marker?
Sorry.
Thank you. So first of all, we can write this like depending on the time. Okay, well, this equation uses as independent variable the time.
Okay.
That's because when we are looking to the derivatives, also the denominator it's our independent variable, and we can write this like p of t is equal to it's supposed to be a position. Okay. Okay. All that we need to understand is that when we have an independent variable, it affects a dependent variable. In this case, the position. When we are talking about cinematic, all of our possible components of the movement are depending of the time. So here we have this function that the derivative of p by t, in this case the time, it says that okay, yeah. So when we are trying to look for the antiderivative, it's like kind of simple of the integral, but it's not the same, because we need to understand that all our function will need to be independent of time. So here in this part, I don't have the time. It's only saying that the position is 0.02. So it doesn't say anything more about how it moves through the time, how is the acceleration of this object, or this supposing object. So to make this, we need to separate it, or to understand that we need to put the variable of time inside this function. So it's supposed to be 0.02. It's a constant, so we only need to do dp, d time, okay. Yeah. Okay, so it's supposed to be that the integral will need to be in function of time.
But that's a different function, because in there you're writing the derivative of p over time, right?
Yeah.
And in there you have only p.
Yeah. Sorry.
So what you're saying is correct.
Okay.
You cannot obtain that derivative in a direct way,
Yeah,
because you have p instead
it's
of p.
complicated, but
So how would you obtain that derivative?
well, first I will look for
example, think about the methods that we learned.
okay.
Is there any way to find an antiderivative that is not the direct calculus?
Okay. Well, to look for the antiderivative, well, the problem is that we don't have like such this in function of time, but we have to put inside it. So we can, well, we can do it inverse, no? So we can make it this upside down, like, because I remember that we have some exercise about it when we use like xt and also a constant, and we decided to integrate it in function of t, no, of x, and it was like in a bar sign, I think. Well, if this is saying that the derivative of p in function of time, it's supposed to be 0.02p. So we can do it like, okay, so this is saying that depending of time, the position of, it's supposed to be initial position.
Okay, Darian, for example, if you obtain function as the position that depends on time by solving that equation? Can you obtain a mathematical expression for it?
Well, I can write that the derivative of position, well, I only clear it, it could be 2. Okay, maybe it could be like this. 1 over 2p derivative time, or I have it. Well, no, it cannot be like this because I don't have the time. So I need to change this to working function of p and then integrate it in time. So
we saw one method in order to solve that kind of problem. Which method is it?
well, it's because we look for Euler, we look for the antiderivatives, and we look for the problem here is that I don't know how to. Well, I can substitute it. Yeah. So I can. Okay. I have p in both sides. I have t. How can I write it in both sides? The only way to do it is. Well, I can. If p, it's supposed to be p. The problem is that I don't know how to separate this to make only in function, to separate it in p, because I don't remember how to do it when I have t or only the number inside of
So
this.
if you cannot do it in an analytical way,
Numerical way, with Euler, yeah. I would think about it, but I don't remember. So it's supposed to be that depending. Okay, yeah, this is a function, so if I derive this function, it's supposed to be.
yeah. So you can use the Euler.
Yeah,
right?
yeah. So with having this both, so if I have p, I can take it as f. And you can write it out. You can write it this as f of x. In this case, of t, and I can imagine that the result. Okay. So I can imagine that in the function of Euler, in this case, this could be, yeah, it could be y. And this, no, it's supposed to be p. P, E, S.
So don't worry, if you do not remember the formulas, that's okay.
Yeah, but no, but I remember it. It's supposed to be this in function of, yeah. P1, yeah, P1 plus the derivative of t for h. So here I can only use the p that I know, and t will be my x. It's like changing it for the values I have. If I know that p is my dependent variable, I can work like p is equal to y, and if I know that my independent variable is t, I can work it like t is equal to x, so I can substitute it all inside of Euler, and I can start to do it in a numerical way by my own or in a mathematical program.
Okay.
Thank you.